Welcome to Lesson 3, Phase Changes and Heat. Our lesson objectives: identify if a substance is a solid, liquid, or gas, determine if a phase change is endothermic or exothermic, and differentiate between potential and kinetic energy changes on a phase change diagram. When we look at solids, solids have a definite shape and a definite volume, meaning if we place a solid into a larger container, it's going to retain its shape and the amount of space that it occupies. When atoms or molecules are in the solid phase, they are packed tightly together in this geometric or crystalline pattern, as you can see here, and they are vibrating constantly in place. Liquids have no definite shape, meaning they take the shape of the container that they are placed into, but they do have a definite volume. They do have a definite amount of space that they occupy. When atoms or molecules are in the liquid phase, they are, as you can see here, further apart than in the solid phase, but they are closer together than the gas phase. Due to this increased amount of space between the atoms or molecules, they are in constant motion and they can flow over each other. Gases have no definite volume. They will always fill the entire container and they have no definite shape. In the gas phase, the atoms or molecules are in constant motion and they actually have the most amount of movement between them in comparison to the solid or liquid. They have no arrangement to them, and as I mentioned, they have the most amount of space between the atoms or molecules, which allows for that amount of movement. So what holds a substance in the solid, liquid, or gas phase? Well, these are forces of attraction between the particles. So in the solid phase, there's the strongest force of attraction between the particles, and that makes sense. That's what's actually holding it in this regular geometric pattern here. The liquid phase, there's a moderate force of attraction, so there's less than solid, and that's why you can see these atoms or molecules are allowed to spread out more. And then the gas phase has the weakest force of attraction between these particles, and therefore these atoms or molecules will spread out even further, and that's what allows them to move more and more due to this limited attractive force between the particles. So let's check your understanding. Can you identify if a substance is a solid, liquid, or a gas? So now that we investigated the phases, let's look at some phase changes, going from one phase to the next. So going from the solid to the liquid phase would require adding heat. Adding heat is called endothermic. And so going from a solid to the liquid, the phase change is called melting. So what's taking place when a substance melts? Well, in the solid phase, we have the stronger forces of attraction. And so when we add heat, these atoms or molecules will start to move more and more and eventually overcome those attractive forces and start to spread out into the liquid phase. Going from a liquid to the gas phase, that phase change is called evaporation. And so same thing, as we add heat to our atoms or molecules in the liquid phase, they start to move more and more and further overcome those attractive forces and spread out even further. There's also a phase change which skips the liquid phase and goes directly from a solid to the gas. A good example of this would be dry ice, which is solid carbon dioxide, CO2. If you recall, CO2 is a nonpolar molecule, meaning it has a symmetrical distribution of charge. So it is not a dipole. And therefore, it has very weak attractive forces to its neighboring CO2 molecules. So it has very weak intermolecular forces. And since they are so weak, when you place solid carbon dioxide or dry ice in an environment that has, let's say, for example, room temperature, that has a lot of heat energy, that heat energy very easily overcomes these weak intermolecular forces, and therefore they're not strong enough to hold it in the liquid phase. And so it skips that phase altogether. So again, solid right to a gas, that is called sublimation. Now if we remove heat, go in the opposite direction, that's called exothermic. Exo like exit, therm meaning heat, so heat is exiting. If we're in the gas phase and we remove heat, these atoms or molecules start to slow down, the attractive forces start to become greater, and they start to be pulled in closer together. And so that first phase change going from a solid to a liquid is called condensation. The particles are condensing to the liquid phase. If we continue to remove heat, these atoms and molecules start to slow down even more, and it goes from a liquid to a solid, which is called freezing. The opposite of sublimation is going directly from a gas to a solid. And so by cooling, exothermic, removing heat, going from a gas to a solid is called deposition. So let's look at these a little bit further. So for the endothermic processes, adding heat, if we go from a solid to a liquid, that's melting. And we notice that heat is a reactant. It's on the reactant side of our arrow here. And so we're adding heat to take these solid atoms or molecules and start to spread them out into the liquid phase. Going from a liquid to a gas, again, heat on the left-hand side, the reactant side, that would be vaporization, evaporation, or boiling. And so we're taking these liquid atoms or molecules, and the energy is going to further separate them into the gas phase. And then going from a solid directly to a gas, again, heat being a reactant, that is sublimation. For exothermic, removing heat, going from a liquid to a solid, now notice that heat is on the right-hand side. It's a product. It's being removed, so it's actually producing or giving off heat. And by removing heat, going from a liquid to a solid, we call that freezing. And so when we remove heat, you'll see that they slow down, and the attractive forces will start to become greater, and it pulls them in even closer into the solid phase. Going from a gas to a liquid, again, notice heat is our product, so we're removing heat. That is condensing. And it kind of makes sense if you're going from a gas to a liquid. You can see that these atoms or molecules are coming closer together. They are condensing. The word condense means come closer together. And lastly, going from a gas directly to a solid, that's the opposite of sublimation. That's called deposition. Again, heat being on the product side. So let's check your understanding. Can you determine if a phase change is endothermic or exothermic? And lastly, let's look at the thermochemistry, which is the study of changes that occur in chemical reactions. And we talked about kinetic energy before. That's the energy of motion, and potential energy is stored energy. So looking at a phase change diagram then, if you look at all the phases of matter here, we have the solid here, we have liquid, and we have gas, you'll notice that temperature is increasing. Well, temperature is a measure of average kinetic energy. So therefore, if temperature is increasing, so is kinetic energy. So during all of these phases, there is an increase in kinetic energy. But if you look at the phase changes, here we have freezing, melting, and here we have condensing and boiling, or condensing and evaporation, you notice that temperature is not increasing. So therefore, kinetic energy is not increasing. So then what is increasing if I am adding energy over time? That's the potential energy. And so the potential energy is the energy being used to actually overcome these attractive forces in these phase changes. So let's check your understanding. Can you differentiate between potential and kinetic energy changes on a phase change diagram?